Hi, my name is Keshav and today our topic was Bayesian analysis of Bayes theorem. Frequencies. The popularist view of probability is so-called frequencies approach, whereby the probability P of an uncertain event A, P of A is defined by the frequency of that event based on previous observations. For example, in UK, 50.9% of all babies born are girls. Suppose that we are interested in event A randomly selected baby is a girl. According to the frequencies approach, P of A is equal to 0.509. Bayesianism. The frequent approach for defining the probability of an uncertain event is fine providing that we have been able to record accurate information about many past instances of the event. However, if no such historical database exists, then we have to consider different approach. Bayesian probability is a formalism that allows us to reason about beliefs under conditions of uncertainty. If we have observed that the particular event has happened, such as Britain coming 10th in medal table at the 2004 Olympics, then there is no uncertainty about it. However, suppose A is a statement, Britain sweeps the boards at 2012 London Olympics, winning 36 gold medals. However, suppose A is a statement, Britain sweeps the boards at 2012 London Olympics, winning 36 gold medals. Since this is a statement about a future event, nobody can state with any certainty whether it's true or not. Different people may have different beliefs in statement depending on the specific knowledge of factors that might affect its likelihood. Sporting was continued. For example, Henry may have strong belief in statement A based on his knowledge of current team and past achievements. Marcel, on other hand, may have such weaker belief in the statement based on some inside knowledge about the status of British sport. For example, he might know that British sportsmen fail in bids to quality of Euro 2008 in soccer, win the Rugby World Cup and win the Formula 1 World Championship all in one weekend. Thus, in general, a person's subjective belief in a statement A will depend on some body of knowledge K. We write this as P of A by K. Henry believed in a different of Marcel's because they are using a different case. However, even they are using the same K, they might still have different beliefs in A. The expression PA of K thus represents a belief measure, sometimes for simplicity, then K remains constant. We just write P of A but must be aware that this is a simplification. Bayes theorem. True Bayesians actually consider conditional probabilities as more basic than joint probabilities. It is easy to define P of A by B without reference to joint probability P of A comma B. To see this note, we can rearrange the conditional probability formula to get P of A by B into P of B is equal to P of A comma B. By symmetry, P of B by A, P of A is equal to P of A comma B. It follows that P of A by B is equal to P of B by A into P of A by P of B, which is also so called Bayes rule. Why are we here? Fundamental difference in experimental approach. Normally reject or fail to reject H0 based on the arbitrary chosen p-value conventionally less than 0.05. In other words, we choose our willingness to accept a type I error. This tells us nothing about probability of H1. The frequentist conclusion is restricted to the data at hand. It does not take into the account previous valuable information. In general, we want to relate an event E to a hypothesis H and probability of E given H. The probability of H is being true is determined. A probability distribution of the parameter or hypothesis is obtained. You can compare the probabilities of different H for the same E. Conclusions depends on previous evidence. Bayesian approach is not a data analysis for SE. It brings different types of evidence to answer the questions of importance. The given prior state of knowledge or belief, it tells us how to update beliefs based on observations. Current data. Our hypothesis is young actors have more probability of becoming drug addicts. We took random sample of 40 people, 10 of them were youngsters, being 3 of them addicted to drugs, from the other 30, just 1. Young actors, D plus YA plus is 3, D minus YA plus is 7, D plus YA minus is 1, D minus YA minus is 29. Total of 4, 36, 10, 30, 40. With frequentist approach, we will test H1 conditions A and B have different effects. Young actors have different probability by becoming drug addicts than the rest of people. H0. There is no difference in the effect of conditions A, B. The statistical test of choice is lambda square and Yates correction. X square is equal to 3.33, P is equal to 0.07. We can't reject the null hypothesis, and information the P is giving us is basically that if we do this experiment many times, the 7% of the times we will obtain the result if there is no difference between both conditions. This is not what we want to know, and we have strong beliefs that the young actors have probability of becoming drug addicts. With the Bayesian approach, we want to know P of D plus by P of YA plus is greater than P of D plus by P of YA minus. P of D plus plus P of DA minus is equal to P of D plus and P of YA plus by P of YA plus. Then you will get the answer of 0.3. Then P of D plus by P of YA minus is equal to 0.033. 0.3 is greater than 0.033. Therefore, P of D plus by P of YA plus is greater than P of D plus by P of YA minus. And here you will get the of Bayesian approach. This is Bayes' theorem. You can see on this slide. An example. Suppose that we are interested in diagnosing cancer in patients who visit a chest clinic. Let A represent the event person has cancer. Let B represent the event person as smoker. We know that the probability of prior event P of A is equal to 0.1. As basis of past data, 10% of patients entering the clinic turn out to have a cancer. We want to compute the probability of posterior event P of A by B. It is difficult to find this directly, however, we are likely to know P of B by considering the percentage of patients who smoke. Suppose P of B is equal to 0.5. We are also likely to know P of B by A by checking from our record the proportion of smokers among these diagnosed. Suppose P of B by A is equal to 0.8. We can now use Bayes' rule to compute. P of A by B is equal to 0.8 into 0.1 by 0.5 is equal to 0.16. Thus, the light evidence light of evidence that the person is a smoker, we revise our prior probability from 0.1 to a posterior probability of 0.16. This is significant increase but still unlikely that the person has a cancer. Another example. Suppose that we have two bags for each containing black and white balls. One bag contains 3 times as many as white balls as blacks. The other bag contains the 3 times as many as black balls as white. What is the probability that we are using the bag with mainly white balls? And here gets you a solution. The big advantage of Bayesian approach. Evolution principalized approach to the exploitation of all available data, with emphasis on continually updating one's models as data accumulate, as seen in the consideration of what is learned from the positive monogram. And here is the Bayesian reasoning. And here is the compact formulation. C is equal to cancer present, T is equal to positive test, P of A by B is equal to probability of A given B. It is not. Prior probability is P of C equal to 1%. Conditional probability is P of T by C is equal to 80%. T of P of T by not C is 9.6%. What is the posterior probability? By using Bayesian reasoning, we can tell the probability. Here is a simple of Bayes theorem. Common mistake to ignore the prior probability. The condition probability slides that the revised probability is its direction but does not replace the prior probability. A natural frequency's presentation is one in which the information about the prior probability is embedded in the conditional probabilities. Test activity issue. Where do the priors come from? In addition to the WLS estimators and the classical interference SPM also to Bayesian estimation and interference. In this instance, the statistical parametric maps become posterior probability maps PPMs, where the posterior probability is probability of an effect in given the data. There are no multiple comparison problem in the Bayesian interference and the posterior probabilities do not require adjustment. Thank you.